All right, so to solve this system of three variables and three equations, I need to choose which variable to get rid of, x's, y's, or z's. I'm going to go ahead and pick the y's just because there's a couple negatives here, and so I won't have to worry about switching signs. If I get rid of the first with the second and the first with the third, I can worry about the number but not have to do the negatives as well. So let's say I take the first two, and I'm going to have to multiply the top equation. I'm making a 12 for those y's, right? So I'm going to have to multiply the top equation by 3, the bottom equation by 4, and that's going to make a negative 12. So I will have 15x plus 12y minus 15z equals negative 24. And then 8x minus 12y plus 8z equals negative 24. All right, so the y's are adding up to 0 here. And for the x's, it looks like I'm going to get 23x minus, it looks like 7 here for z. And then those are both negative, so negative 48. So I've got some large coefficients here. It's just going to have to deal with that. And then next, I'm going to go ahead with my initial choice that was going to use the top equation and the bottom equation because they just had opposite signs. So I figured that'd be convenient so I wouldn't have to worry about those negatives like I said before. So we're going to go for 20s here. So our top equation, we're going to need a 5. Our bottom equation, we're going to need a 4. So that's going to give us 25x plus 20y minus 25z equals negative 40. And then 24x minus 20y plus 24z equals, I gotta check real quick on my calculator to do the 26 times 4. So 104, so negative 104. All right, and we'll add those up. The y's will add to 0y. And looks like 49x. And then minus z equals negative 144. Okay, so now we're going to use these two equations together. Um, it looks like z is going to be easiest for me to eliminate because of the one coefficient, so I can make that a 7 much more easily than I would be able to make the 49 and 23 into the same number. So let's take the bottom equation, this one over here, times, we want it to be a positive 7, so that it will add to 0 with that negative 7 here. So we're going to multiply by negative 7. And again, I'm just going to type in my calculator real quick, 49 times negative 7. So this gives me negative 343x plus 7z, and then negative 7 times 144 gives me 1008, and then I can write down my other equation with no changes because it had already had the negative 7z to add to that positive 7z and get to 0. Okay, so I've got negative 343 plus 23. That gives us negative 320. X equals, and I've got 1008 minus 48, which gives us, I typed that wrong, there we go, which gives us 960. And if we divide these, 960 divided by negative 320 gives us negative 3. So luckily, with those large numbers, this all came out to a nice little whole number for x, so I'm happy about that. All right, so now that I know x, I can plug it into either one of these equations to solve for z. I still prefer this one just because the numbers are smaller. So I'm going to use this one. The number of z is smaller. I guess some of the other numbers are bigger, but I'm going to use this one here. So I got my 49 times 3 minus z equals negative 144. So I need 49 times 3. That's 147. Minus z equals negative 144. I like to just add the z to the other side. So I'm going to add the z over here. And then I should be able to add the 144. That's going to be huge. So I just realized I lost my negative on this 3. I think I had said that it was negative. I better go put that back. So this is actually a negative 144 right there. I apologize for losing that negative on there. I realized that when I was getting those two numbers, I'm like, something's not looking right. Of course, it was supposed to be a negative 3 right here. I just didn't write it down. So the negative 3 times 49 created the negative 147. If I add the 144 over and add the z to the other side, the z will become positive. And then negative 147 plus 144 is going to be negative 3. So I get another negative 3 for my z value. All right, so I've got the x value, the z value. We're going to go back into one of the original equations to find the y value. I'm going to go with that middle one just because the numbers seem to be the smallest. So 2 times x, which is negative 3, minus 3y, plus 2 times z, which is negative 3, equals negative 6. So that's negative 6 minus 3y minus 6 equals negative 6. Negative 3y minus 12 equals negative 6. I can add the 12 to both sides. The 12 just came from adding up those two negative 6's. Negative 3y equals 6. And it looks like I'm going to get a negative 2 for the y value. So my solution is coming out as negative 3 for x, negative 2 for y, and negative 3 for z. We can check this with all of our equations. I will pull over my decimals window here for my quick check. All right, let me get my pens out of the way. So in the top equation, we have 5 times x, which is negative 3, plus 4 times y, which is negative 2, minus 5 times z, which is negative 3, and it gets us negative 8, so that one checks. All right, then it's 2 times x minus 3 times y plus 2 times z, negative 6. That one checks as well. Then it's 6 times x minus 5 times y plus 6 times z, negative 26. So all of them check.